Today we're introducing the multi-protocol link breaker from Quarch. This standalone fault injection unit is designed for automotive, aviation and similar industries where communication links are safety critical and must be robust. It uses pluggable screw terminals for easy connection into a wiring loom, and these can be removed and inserted quickly. We support everything from I2C and SPI up to 1000 base T1 links, plus a power rail. We provide USB and LAN control, and power comes from either power over Ethernet or an external 12-volt supply. First of all, TestMonkey is great for training, evaluation and prototyping new tests. We can connect to a module and then make or break the link with just a couple of clicks. Here we can see all the signals. There are 4 digital lines and 1 power rail, and we can break or connect any of these in real time. First breaking the power rail, then turning off one of the data lines. We can also assign one or more signals to a different control source, allowing for more complex events. Here I'll use source 2 and set a delay of 25 milliseconds. This will make the power rail connect slightly after the data lines as soon as we perform a plug or pull action. We can drag these around quickly, and we can also add pin bounce to the signal. Here we'll use a millisecond of bounce at 500 microseconds period, but practically anything is available, and again you can drag and move these quickly to create different tests. And next we can glitch a signal, breaking it for a very specific period of time. Here I'll select just one of the data rails, and with a single click I can create a 50 nanosecond glitch on that rail, blocking data for that time. We can also repeat that, so we'll get the glitch every 100 milliseconds until we want to stop. And we can also use the built-in PRBS generator to place a random sequence of those glitches in a ratio. So here, 1/64th of the time when the bus will be disrupted on average. Triggers allow us to run a plug, pull or glitch based on an external trigger from another device. And similarly, we can trigger out on these events to set some other piece of test equipment, such as a traffic analyzer off. Next, let's look at Quarch Power Studio. And while it doesn't measure power, we can use QPS to view or capture the live bus transactions. And we can see all the channels here and select what we want to view. We track both data in and out of the unit, and also the state of the switch and the validity of the power rail. So these are all available to you. Now let's bring up the link and see some real data. You can see the power rail became valid first, and then we get bursts of data going on. We track both data in and out of the unit, and then we can come back and view later, zoom in on any part of the trace that you need to get more detail on. So let's grab a section and zoom in further, and then further again, and see exactly what's going on. So we can start to see the individual transactions on the bus here, and again zoom in one more time. All of this can be exported to CSV for post-processing. We can also add annotations to the trace if we're going to share this with others for a discussion later. Can we just enter a quick annotation example? Annotations can also be colored, moved later, etc. And both QPS and the device itself can be automated from Python via our Open API. You can inject faults and capture live data with just a few lines of code. And our site has examples, application notes, and of course our engineers are happy to help you get started. Thank you for watching.